Hello, everyone. I'm Amin. Good morning to our morning talks on data science related topics. And I'd like to introduce you to Xiao Li, who is our first speaker in this session. He comes to us from Databricks, where he's an engineering manager and is part of their Apache Spark public libraries, and he'll speak to us about Koalas, which is like an implementation of the Pandas API on top of Apache Spark. So I think it can make a lot of help to a lot of new developers who want to use Apache and things. Thank you.
Yeah, thank you. Thank you, everyone. So today I will talk about a new project, open source project, Koalas. So that unifies the Spark and the Pandas APIs. So let me introduce myself. So I work for Databricks. I'm leading open source team for Spark contribution and also this new projects, Koalas. So I'm the Spark committer and PMC. Previously, I worked for IBM. I was an IBM master inventor. And my focus on the Spark, database replication, information integrations. I got my PhD from Florida, so that's why I did have ideas at Data Smile. Yeah. So Databricks is founded by the original team who created Spark. We provided a unified platform that accelerates innovation by unifying data science, engineering, and business. It is powered by Spark. It is available in both Azure and AWS. Okay, so let's talk about Spark first. So Spark basically is the de facto unified analytics engine for big data. So it has many different use cases, like just-in-time data warehouse with data support. Like Data Lake is a new open source project that support ACID transaction, and also like merge, update, delete. It is built on top of a packet. So and also it has many other different use cases like streaming, ETL, machine learning, graph processing. In the upcoming Spark release, we will have a new module called Spark Graph. So that was contributed from the new 4J. And of course, we have many different API language binding, like PySpark is an API for Python users. And also the other APIs like Scala, R, SQL, and Java. So in the last few years, you can see there's the Python user base is growing super fast. We expect the Python users, Python will become the top one programming language in everywhere. So Pandas was created by Wes in 2008. So it's basically it's a standard tool for data analysis in Python ecosystem. It is deeply integrated into the Python data science ecosystem, like NumPy, and also can deal with a lot of different situations. Let me first. There's some notification. Okay. Pandas is very popular for data scientists. So the learning curve is short, and it provides a simple API for the common task. Basically, you just need to search and find the API, then copy and paste, and then it works. But why the Spark is also very important for data science? So it performs faster, actually, especially for the big data. So let me explain the major reason why it is faster. First is it is distributed computation platform. And it is more lazy. When you execute, basically you first need to trigger the execution until you call the action APIs, like collect, save, and show. When you trigger the execution trigger, so basically we'll build a big logical plan. So based on your API, Spark API. So mix, combine, and reorder, and optimize, and execute it. So the optimization, execution is, is holistic. And also the Spark execution is based on the last 30 or 40 years database research. So like our execution engine is using whole state code gen. And our optimizer is heuristic-based, cost-based, and in the upcoming 3.0, we also will introduce adaptive query optimization. So that means at runtime, we collect the data based on your input data set, and we will change the plans at the runtime. Let me explain a little bit why the users try to Spark-ify the Pandas code. So normally at the very beginning, so for most of data scientists, they are very familiar with Pandas. So that's why they use Pandas Python code. It's very simple, easy. But the data becomes, the data sizing is increasing, become much bigger, and the complexity is also increasing. In this case, so they will see the Python code is very slow. So that's why some users try to migrate their Pandas code to Spark, but it is not easy. It's not straightforward. Because PySpark is using different concept, and the API is totally different from the Pandas API. It's very easy to make a mistake. So our solution is Koalas. So this years, we announced these new projects. At the beginning of this year in Spark Summit. It is a pure Python library. It will be very easy to use if you are existing Pandas users. Basically, it provides Pandas APIs on top of Spark. So we implement this Pandas API using the Spark execution API. So it unifies the two ecosystem with the familiar API, that's Pandas API. It's very easy to switch from the small data to the big data, and but maybe you're curious why they're different. How they're different. So Pandas API was following the battery included philosophy like the other Python library. It providing API for the common tasks, and the type system is from NumPy, and there is a pure Python library. But the PySpark is following the SQL standard. And also we have to make sure the API are consistent with the other languages, Scala API, Java API, and the behavior has to follow the SQL. And so we don't provide enough API for the common task. We expect the task can be implemented by function composition, but it's not simple or not good for the end users, especially for the data scientists. I think we made a lot of mistakes. So that's why, let's compare the difference using very simple examples. First is like columns. If you want to select the columns using Pandas DataFrame and the Spark DataFrame, same. But internally, they are different. So Pandas DataFrame is immutable, and the Spark DataFrame is immutable. It's hard to say which one is better. It depends on use case, your background. If you want to add a column to an existing DataFrame, like in Pandas DataFrame, you just need to assign For example, this is the example. So we want to select, create a new column C by using the existing column A and B. You basically plus them together and then assign to C. That's it. But in the Spark DataFrame, you can see it is very like a SQL. So first you get the DataFrame, basically that from the table, and then you create a new column C, and assign the DFA plus DF2 B to the C. If you rename here, Pandas API, very simple. You just set the name AB, and so it will change the name automatically. But in the Spark side, you first need to select these two columns, and then do the rename. It will generate a new data frame. It's not very straightforward if you are not SQL users. Even worse, like value counts. In the Pandas data frame, you just call this simple API, value counts. You return the number of values for this column. But in the Spark data frame, you need to select the data frame column, and then group by, and then count. And because sorting is not cheap, especially for the big data, so we don't sort for yourself. So, but in the Pandas data frame, it has an index, so it is very cheap. Here you have to specify which column you want to sort. It's just longer and not easy. So let's give another very, simple example. First is you want to read the data, CSV files, and then send some column name, and then create a new column x2 using the existing column x. It's a very, simple, right? But in the PySpark side, you first need to create a Spark session and read this CSV file and set some options. Maybe you have no idea what's the options we provide. And the default value might be different from the Pandas, so you have to change. And also, the rename is also different. It's not very friendly, especially for the Pandas users. Okay, now for this new project, Koalas, it's very simple. You just import the Koalas and then replace the PD by test. That's it. It works. So Koalas basically follows Pandas. So it provides a large set of discoverable API for the common data science task. And it unifies the Pandas API and the Spark API. But when there are conflicts, like the same name, different return value, return types, we respect the Pandas. And for Pandas API that as long as appropriate for the distributed data set, we just implement that. And also, we also add some API for distributed computation, make it perform faster, for example, cache. It is Spark specific, but it will help you to avoid recomputation, because recomputation is very expensive. So so we unify this API together to make your life much easier when you try to migrate your Pandas code. And also, maybe we don't support all types of API, or for either Pandas or Spark side. So for the Koalas DataFrame, we have some API you can easily convert from the Koalas API DataFrame to the Pandas or NumPy, or you can convert back. Also, you can convert to the Spark DataFrame directly. So if you also know how to use the Spark. So let's give you a big picture of what they are. So Koalas is built on top of the Spark and the Pandas. And so that's why it can utilize the Spark execution engine optimizer directly. And the reason why I also add the Pandas here is because when we implement Koalas, for some APIs, we directly use existing Pandas API. In the Spark 2.3, we introduced some new UDF type called Pandas UDF. So you can just use the Pandas API directly in the definition of the Pandas UDF. But for most of users, it's not very straightforward. Even the API is simple, but we have like different types of Pandas UDF, and you need to install many things. You have to use it correctly. So here, the Koalas basically help you to implement this Pandas API to make it more scalable for the big data. And also the API layer, we don't have like execution logics. So it's very lean. We can move it very fast. So we can release the new keep the whole project very, the release speed is very fast. Okay, let's give a very quick demo and show you how to use the Koalas. So this is a notebook, David's notebook. It's a little bit like the Jupyter. Yeah, it has some helper functions, but yeah, you can ignore that part actually. So firstly, this demo is just to use a fire department calls for service. The data set is from the data SF. So the goal is to predict the time it takes for fire engine to arrive on scene from receiving the calls. So first, maybe let's make it bigger. You just need to first import the Koalas library. Then, this is the example just to show you how to read the CSV file using the Pandas. Yes, this is Panda API. It's not the Koalas API. pd.read CSV. You can see it takes 1.28 minutes. It's very slow. I don't run this one by one. Okay, then it's the Koalas API. It uses like a very totally same syntax, but internally it is to use a Spark. It's Spark DataFrames. So you can see, yeah, you can view and click and to understand more details about this if you want. Yeah, the Spark UI, you will see the details, how to do it. We have 32 tasks. We run it at the same time, make it perform faster. So that's why it just takes 7 seconds. 7 seconds. Here is 90 seconds. It's almost more than 10 times faster. But this is just a typical use case. Why it is faster? Because first it's distributed. It read the CSV file. Different partitions at the same time. Yeah. Oh. Okay. Maybe let's look at something. Okay, this is the previous another one. So it has comments. Maybe it will be easier for you to understand. I don't know, repeat everything. So this is basically, we want to look at the few rows using this Koalas DataFrames. Here is basically calling the Pandas API head, and it will return the table, the first few rows. And also, you can basically call the shape. This is also another Pandas API. We Koalas support. It will return the number of rows and the number of columns. And also, you can know the data types. This is also Pandas API. We support it. Yeah, you can see this is a return types. Of course, if you are familiar with Spark APIs, you can convert to the Spark DataFrame and then call print schema. So it will, this is the output of the Spark. It depends. Some API, maybe you like Spark better. Also, this is another Pandas API. So this command just shows some basic statistics. You can call it describe and reset index. It will output this. So of course, Spark also has some similar API to show you the basic statistics, but yeah, maybe they're not the same. So maybe you like this one better. So yeah, you always can use Pandas API. And also can show you how much data is missing. This is also supported by Koalas. So it's NA and dot sum. It will output this. So see the call number based on different columns. So here we are trying to do something using the machine learning to predict the response time. So here, first we need to drop the missing values. So for these two columns, we generate a new data set. And then we convert this data types object to the date time. So Koalas also implemented this to date time API by using the Spark. So it will first return convert this column on sync date time. It gets the first 10 rows. So here it just show you. And also another column called receive data time. To get the delay, basically you just minus two columns. Yeah. So first you need to convert to date time, then do the minus. Then you can get a delay. Very simple. And also get the first 10 rows. Okay, then you can select the feature. So for these four columns, the last three is from the original table. The first one is basically it's a newly generated columns. Okay, then you get the first 10 rows. Okay, so this is. Okay, then after that, you can call the value counts to get the number of distinct values. You can see here, some results. Okay, now you can do the feature engineering. So we also support get dummies. And you can display and see this is the results. And after that, we just apply here. We just apply the pre-trained model using MLflow. I'm not sure you use MLflow or not. So this was a new project led by the Spark father, Mate. So basically, MLflow can help you to manage the machine learning models. It's very easy to use also. You just load the model. And then you just use the model directly, okay, predict the validation features. So this is the result. You can see it's very easy. So basically, this is a very, basic flow. Okay, let's go back to our talk. Okay, so let's give some updates about this project, Koalas. So this is bi-weekly release. So every 2 weeks, we have a new release. Each release has more than 5 new features. We have 2 dedicated Spark PMC working on these projects every day. So now we already basically implement 60% of Pandas DataFrame series APIs, 50% DataFrame group by and series group by APIs, and then 15% of index and multi-index APIs. And many other utility functions like to-date-time, get dummies, and also other some Koalas specific API called to-delta. So basically, you write the data to delta format. Also to parquet, write parquet tables and parquet files, and also any built-in data styles supported by the Spark, like JSON, CSV, JDBC, and text, and yeah, a lot of different data sources. And also, if you are familiar with SQL language, you can also use a SQL statements, just called ks.sql, and of course some cache, some other API. So you can see, since the starting, the daily usage and downloads number is already more than 7,000 last week. Also quickly grows. 20 significant contributors outside of Databricks, and more than 300 patches since the initial announcement. So we will, keep adding the new features in the upcoming releases, like improve the performance of the better index support, and improve the error handling. We heard a lot of complaints about our error handling in the PySpark, like the Scala state trees, Java state trees is very hard to understand. And we try to improve that in the Koalas side also. And also add more Pandas APIs and have a more better support for time series and the visualization support, like the plotting, to implement many different types of plotting. It's very easy to use Koalas. First, you can pip install and then conda or conda install. The docs is much better compared with PySpark. It has many different examples, very detailed description for each function APIs. You can get the doc from this link, read the docs.io. And if you have any suggestion about our projects, you can submit the request to Koalas, create an issue, new issues. And also very easy to contribute. We have a contribution guideline. The maintainer of these projects will help you to review and merge your peers. They are very active. Okay, thank you. Thank you, everyone.
Does anyone have questions?
Thanks, Xiao. I really like this new API. It's so easy, so intuitive, and I also like you have an option to convert it back to Spark in case people are familiar with Spark. Since you work on DataBricks, I have a question. Do you have a project like convert the data structure, make it easy for PyTorch machine learning library? You already have a Spark machine learning library. Do you have anything to integrate with, say, PyTorch or Keras?
In Databricks platform, we integrate the PyTorch, TensorFlow, all this framework to our products. But we don't have like a conversion, something like Koalas to do a migration from like Spark-ML to PyTorch or from PyTorch to Spark-ML. We don't do it, but maybe in the future we can do it. But now we don't have the plan. Yeah, thank you.
So whenever I see these types of libraries, I wonder about what is the performance overhead of using this API that's providing this nice capability for me, compared to, say, base PySpark, for example.
Yeah, so of course, if you want the best performance, I would suggest to use Scala. But I mean, compared with PySpark, I think the performance overhead is very small. Next week, we have a customer who uses Koalas. They will publish a blog to explain what they did and also give some like performance number and compare like Pandas, PySpark, and also Koalas. Yeah, maybe next week. So, yeah, thank you. Okay, thank you.
Can you support something like apply, so that to pass a generic Python function to Pandas apply?
I think we do support, but I mean, maybe there's some gap, but yeah.
There's a, you can pass a function and act on each column or each row if you change the dimension. And I was wondering, if it would be the maximum flexibility. If you can support and apply, then you can do anything. I'm going to try it
Yes,
On the
please
way
try.
back home, I don't even get home.
Okay, if you have hit any problem, open the issue. We will respond your very quickly.
I always have problems. That's not a problem. Yeah.
Okay, thank you. Yeah.
Oh, so my question is another follow-up on the performance question. So you mentioned in one of the first slides that Pandas is mutable and Spark is not. So what's the performance implication of that? Do people need to change their code to get good performance out of this? If you're doing like copy on write or something underneath, how's that implemented?
So in the Koalas APIs, first it is mutable. Just follow Pandas. I mean, internally, it is using the Spark DataFrame. So I think for end users, no difference. I mean, no performance issues. But yeah, but internally, we still use immutable Spark DataFrame.
Sure. So like if I write one cell, is it going to copy the whole data frame?
We will not copy the whole DataFrame. We basically add another columns. Reuse the existing DataFrame.
Okay.
Yeah. But because in the Spark DataFrame it is immutable, right? We just need to add a new DataFrame, a new columns in the existing one.
Sure. Yeah, so if I have a loop that goes down a column and writes to each element, right? Are you going to create n columns where n is the number of rows?
No, it will not generate new rows.
Okay.
Yeah.
Well,
Otherwise, it's too expensive if we do it every time.
Okay.
Yeah. But you can do the dot copy, I think. Yeah.
Anyone else? Okay, then this was the last question. Thank you very much,
Okay,
Xiao.
thank you.